Philips soundbar. So one of my subscribers sent me this. He asked us could I have a look at it. Apparently he bought a job lot of 20 or 25 I think it was of these, and they're all brand new and they've all got the same fault. What happens is after they've been on a while they heat up and overheat and start cutting off. Now he has had a look at one and he's tried changing the amplifier chip and it still does the same thing. So he sent me one to see if I can figure out what the problem is. So there's one of them there, and it comes with the subwoofer, which is just here. We also have a remote control, a power supply and a mains lead. So I think what we'll do is we'll connect a Bluetooth source or something up to it. We'll leave it running for a bit and see if the fault occurs. Right, I'll go and set it up. Right, so it's saying, do we want to pay? So I'll say OK. Right, it's bleeped there. Right, I'll just find some royalty-free music there. And we'll just try turning up the volume. Right, so that's it on full volume, so we'll leave it like that for a bit and see what happens. Right, so it's started to present the fault now. You'll probably hear it cut out in a second, just like there it has, and now it's back on. So the subwoofer part is still playing, it's just the top section that keeps cutting out. There, it's just done it again. So I think we might get the thermal camera out and we'll just have a look, see if we can see anything just around the unit first to see if we can pinpoint where it's getting hot. Right, so I've got the thermal camera out there. Right, so looks about there. You can see the hot spot on the camera there, and obviously I'll put the footage of the camera up on the screen as well so you can see a bit more clearly. Oh, and Kiwi's just decided to come and see what's going on as well there in the background. Hi Kiwi, say hi to everybody. Right, so let's get it downstairs on the blue mat. We'll take it apart and we'll see if we can repair it. Right, I brought it down onto the blue mat, and I think the first thing I'm going to check is that the power supply is giving out the correct voltage. I don't know if you can see there, it says there output 15 volts, 1.6 amps. So let's unplug it. We'll just plug it into an outlet here. I'll just grab the test meter and we'll go on volts DC. And we'll just check what voltage we're getting out of here. And we've got 15 volts. Right, so we can rule out the power supply. Looks like the power supply is fine. Right, so how does it come apart? It's a little bit big to fit on the bench. I just noticed on this end of it, there's some controls there which I didn't notice before. So it looks like there's a screw at this side, about 6 screws in the middle, and then there's a screw at the opposite side there, if I can just get that in shot. There we go. Right, so I shall remove those and then we'll see if we can get inside of it. Let's start by these ones. Well, that seems to do something. Well, I'm not sure whether we need to take the whole front of this off, so does it just come out like that? Right, it looks like we can just get at it like that then. Right, tell you what, I'm just going to spin it round so I've got a better view of it myself, and then we'll zoom down and resume. So it looks like I can remove these 3 screws here, and we can see the other side of the board as well. So I'm going to do that. I think I'll remove this ribbon cable as well. So it should just slide forward and we should be able to remove that. And it looks like we've just got 2 connectors for the speakers here. And a cable tie. Right. Let's move this a bit further back. And we'll zoom down a bit. Right, so what have we got then? Well, that looks like some kind of radio module at this side here. Well, it also looks like there's one here, so I guess that that's probably the Bluetooth module. And this module here might be the one that communicates with the subwoofer, because it's got a wireless subwoofer as well. Now this is the amplifier section, and I believe it's this chip that's getting hot. So it looks like we've got some silicon that we'll probably need to remove there. So I think I'll just zoom down a little bit more if I can. There we go. And we'll see if we can remove this, lift this capacitor out of the way and see if we can remove some of this silicon. I'll try getting a screwdriver under there, I think. See if I can prise that capacitor up. Alright, see if I can pick away some of this silicon now. Right, I'll try a bit IPA on that now, and a toothbrush, and we'll see if we can get the rest of it off. Right, that's a bit better. Just get rid of this bit of silicon. Right, I think I'll bring the microscope in so we can have a look at this chip and some of the components around it. Right, so I've scraped away some of the silicon there, and the main amplifier chip seems to be an ESMT, and it's an AD52068. So I'll see if I can pull a data sheet up for that. Let's have a look over the board a bit, see if we can see anything. I've got a 0 ohm resistor just here. I've started picking away some of the silicon that's around this area as well, just to see if there's any components or anything under there. A bit more around here. We've got some of this brown glue around about this area, which I've been trying to pick away at. But I just noticed something there. Let's just try and zoom in a bit. Now, does that resistor, does that look burnt out? Yeah, this has had that brown glue on it, like the DaVinci stereo system that I just recently looked at. But that resistor definitely looks like it's been getting hot. I think it's a resistor anyway. Or is it a capacitor? I'll see if I can clean that area up a bit with some IP and a toothbrush, and we'll see if we can see anything. Let's try a different brush. I've got some smaller fibre brushes here, I think. A nylon bristle one, we'll try that. See if I can focus on a little bit better. No, it's a resistor, I can see the markings there now. So I can get this glue out of the way. So it looks like R48. We've got C69, which will be that capacitor there, and R48, which will be that resistor there, and that definitely looks like it's being burnt. Definitely looks not right. But how do we find out what value there is? In fact, there's another resistor there. That one looks burnt as well. Let's check the other side on the other output. Yeah, there's a burnt resistor there. And is there another one? And that looks like it there, but that one still looks like we might be able to get the marking off it. Just see if I can get that a bit better. I mean, that looks like 160. So is that 16 ohms? Tell you what, I'll see if I can bring the meter in and we'll just see what that measures. Well, it looks pretty much open circuit. Yeah, but it definitely looks like we've got 4 resistors that have blown. I'll just zoom back out a bit with this. See if we can see anything else blown on this. That looks like a power supply, probably for the Bluetooth module possibly. And looks like possibly another power supply just here as well. Right, let's have a look on the other side of the board, see if we can see anything. Well, round about the amplifier section there doesn't appear to be any components I can see. There's a couple, actually there's a couple of resistors and that and stuff round about here there. A couple of 3.3 ohms I believe. So we've got an IC there. Let's see if I can get a number off it. BK3266L. I'm not sure what that is. Or is it AU815GDA? Another IC here. I'm not sure what that one is. A42S. That doesn't ring any bells with me. A couple of little transistors over another chip here. That looks like a Cirrus chip. An 8422CN. Let's see if we can find what that is as well. That looks like the Bluetooth module. looks like manufactured. Is that the 1st of March 2019, or is it the 3rd of January 2019? I'm not sure which date format they've used on there. And looks like another chip here, which is an FD747011. Which I'm not sure what that is either. Actually, that's part of the little transmitter there. So that's probably an audio transmitter or something, I would guess. And that's where the front panel and LEDs go to. Right, let's go back to the amplifier section then. I'm going to pull up the data sheet for this amplifier section, for this chip, and then we'll see if we can work out what's going on with those resistors. In fact, I don't know whether those resistors are there. I'm just looking here. I'm not sure whether that looks a bit suspect as well. It could just be where it's been scraped when I've been taking the silicon off. Right, I'm going to have a look at that data sheet and then I'll be back. So I've had a look on the internet and I've found the data sheet for the AD52068. So it tells you all the different pins here. So I think what we'll do first, we'll connect it up to the speaker, we'll check some voltages on it, and then I might get the thermal camera out and we'll just have a look, see exactly what's getting hot. Right, so what I've done is I've taken the little front display board from the speaker and just connected it to the main board here with its ribbon cable, so we can actually switch it on with the remote control. I've connected the two speakers up here, and we just need to plug the power in now. So if I connect the power up, like so, hopefully we'll get the light on, yes. And now we should be able to switch it on with the remote control here. So it's right. Right, it's on. Right, so I'll just zoom down a little bit so we can get a bit closer view here. And I'll try and get the test meter in shot as well. Right, so let's see what we get on pin 7. Right, we've got 15 volts going there, and that pin there should be ground. And so we're getting 15 volts going to the chip, so that appears to be right. Let's just see if we're getting any voltages on the outputs. Right, we're not getting any voltages on the outputs, okay. Right, I'll just move the microscope out of the way and we'll bring the thermal camera in, I think. Right, I've got the thermal camera hooked up there, so let's just have a look over this board. Let's find something to point with as well. So that appears to be the little radio board there. There's a little bit of heat coming from there, but not a lot. It's been awkward with that cable being away. You can see a little bit of heat coming from the inductor on the power supply there, and the little chip next to it, just there. I'll zoom down a bit. Another little bit of heat over there. That's probably something on the other side of the board, I guess. We don't seem to be having any heat around the amplifier section at the moment. We're currently not playing any music, so yeah, I'll flip this board over if I can. Yeah, we're getting a little bit of heat from that chip there. and that's from the chip on the audio transmitter. Maybe a little bit heat off that one, but not a lot. Right, so I think we'll start playing some music through it and we'll see what heats up. Right, so I've had it playing now for about 5 minutes or so, just at quite high volume there. I'll just get the thermal camera out so we can see what's going on. And we can see the chip there, which has got a little bit heat on it. But look at these inductors. All 4 of them are like 51 degrees. That doesn't seem right. So all those inductors are heating up. Yeah, 52 degrees, 49 degrees. So I wouldn't think those inductors should be getting hot. I think they're just like a filter on the output. So I think we know what the problem is now, because he said he changed this IC and it didn't make any difference. So I think the fault's after the IC. It seems to be round here somewhere. So I'm just going to switch it off there and we'll just stop the thermal camera. I'm just wondering if there's, well, it can't be a short on the speakers because they're playing. I'm just going to check the resistance of these speakers a second just to see, in case there's anything going on with the speakers. But 4 ohms. Right, so we're using 4 ohm speakers by the look of things. I can feel the heat off them inductors from here. Right, so the speakers are measuring okay. I don't know if there's any capacitors or anything on the inside of this that could be causing it. So after a little bit gentle persuasion, I've managed to remove the front grille. So I just want to check to see if there's any other circuitry in this. I don't think there will be, but it's just worth a look, I think. Because we could be trying to chase a fault on that board, and it might be, I don't know, a blown capacitor or something on the back of this speaker. Right, let's see if that just goes straight at that plug. Right, okay. So there's nothing else in this than just the speaker. Right, so now we know the fault must be on the circuit board here and in this region. So we'll pop that back in. There's nothing in there, is it? And I think there's just a ferrite bead or something in there. I can feel just what the cable is wrapped around. Anyway, I better have a look just in case. I think that's what it'll be. It's like a choke, yeah. Yeah, it's just a ferrite ring with the cable wrapped around. I thought it probably would be. Right, I'll get these cables fed back in here then. And then we'll have a look at this circuit board. So I'm just having a look at the example circuit diagram they've got here. And they're using 22 microhenry inductors. And it looks like this board's using 10. And also they're using 1 microfarad capacitor. And I'm not sure what the values of these ones are. So let's go into capacitance mode and we'll try and measure them in circuit. This might not be accurate, but we'll just it should give her a rough idea. And that says about 5 microfarads. And about 5 microfarads. So we may have to take those off just to be sure and see what the readings of them actually are. Now, it says both of those should go to pin 24, which is power ground, and power ground's actually just another ground. It's like if we go on to continuity now, well, I'll go on to continuity just here. And if I go onto the ground plane here and I go to the 5th pin down, 1, 2, 3, 4, 5, about this one here. We can see that goes to ground, and the 5th one up. So that's power ground, which is this pin here. and that should go to one side of those capacitors and the other side should go to the inductor. So let's try these ones. And a reading of about 400 ohms there. But none of those seem to go to ground. I think I might take these inductors off and clean this board up just to see if we can see the tracks to see exactly what's going on. Because I mean, there could just be a blown track or a track that hasn't been connected properly or something, or it could be something to do with these blown resistors. I mean, do any of those resistors go to any of these? Yes. Let's try that one. And does the other side go to the inductor then? So if I measure, because I would have thought these will be the outputs. Actually the output seems to go to there. I think I'm going to have to take these inductors off and clean this board up so we can actually see what's going on. Right, solder and iron out then. I'll take the top two ones off. Let's see if we can just pull them out. Right, there's one out. And let's do the same with this one. Right, so there's the two inductors out. Let's give this board a bit of a clean up and then we'll zoom down on it. Let's get this diagram out of the way for now. See if I can zoom down a bit. And let's have a little look at this diagram here. So pins 23 and 25. So that's one of them, which goes to the inductor, which is right. And then the other one goes to the inductor, which is right. But then we seem to have this inductor going to that capacitor and this inductor going to that capacitor. But that doesn't seem right according to the schematic that I've looked at. So this is a bit odd. I don't know if I can zoom down any more. Yeah, well that doesn't seem right. So both of them. Yeah, I just don't get that. So this is actually wired up different to what's on the schematic. I wonder if that could be one R note. What I thought was 160. But then again, I don't think that would make sense either, because it looks like it goes from there. It looks like it goes from the positive and the negative through the inductors. I might have to bring the microscope in to have a look at this. I can't quite make it out. So I've spent a little bit of time looking at this board and looking at LC filters on Class D amplifiers, because it's not something I've really came across before. And there is a filter that looks similar to this called a hybrid filter, where there is a capacitor across the two inductors on both the positive and negative side. Now the guy that sent us this, he does have a soundbar that doesn't get hot, but it's a slightly different model. So I've asked him to send us a picture of this part of the circuit, and he has. And interesting to note, it's a slightly different arrangement. I mean, if we look here, there's no capacitor like there is on this one. However, there is still a capacitor across here like there is there. So they seem to have done away with the capacitor that links the two inductors. And also, we can now see those resistors that are blown, which seem to be 10 ohms. So I'm going to have a look for some resistors. I think I'll do away with that middle capacitor, and then we'll try it and see what happens. So I thought I'd just check this inductor as well, just to see what it measures. And it's measuring 0.02 millihenries, which I think is 20 microhenries, and this is supposed to be 10. So I was just wondering if these are being burned out or whatever. So it's still measuring as an inductor, so I presume it's okay. Right, we'll get these inductors back on then. I have to clean the solder off this one slightly. Right, there's one back on. And there's the other one back on. So with that capacitor removed and replacing those resistors, those inductors are still getting up to nearly 50 degrees. So I don't know whether there's a design fault on this or what, or whether those inductors have burned out possibly inside, or I'm not 100% on this one. I don't know whether because they've definitely changed the circuit on the other board that he sent us, and the only difference, it's exactly the same soundbar apart from they've added an HDMI connector, so the sound output would be exactly the same, but obviously they've changed it. Now have they changed it because there's been problems on this model? That's what I kind of think. Right, I think I need to do a little bit more research then. So the problem seems to be on the filtering of this amplifier board. So when I've looked at the datasheet for the amplifier chip, this is the filter that they recommend, which is I think this is called a common mode filter. And basically what happens is the positive output of the amplifier goes through this inductor and then through a capacitor to ground, and the same happens with the negative side. So it comes out of the amplifier through this inductor, through a capacitor, and then to ground, and then the speakers are just tapped off on the inductors. But on this circuit board, it looks like they've tried to implement something called a hybrid filter, I think. And it looks like they're getting it wrong somehow, because, like I said, there was a number of these units that the guy had, all with exactly the same fault, and all of them overheating. So I think what's happening is the capacitors they've used or something must have been sending too much current to ground, causing these inductors to heat up. So what I've done, I've removed all of the components around the inductors, because the inductors themselves seem fine. And what I've done on the back of the board, I've just soldered a capacitor from the output leg of the inductor to ground. So it comes out of the amplifier, through the inductor, to this leg, goes through the capacitor to ground, but then carries on to the speaker terminal. And the same with the inductor on this side. It comes out of the amplifier, through the inductor, through the capacitor to ground, and then to that pin of the speaker. And I've done the same on the other side. So I think we'll try this and we'll see how we get on with that. We'll see if that cures the problem. So I've learnt quite a bit about amplifiers. I mean, I didn't know that this amplifier was a class D, and I didn't know what class A, B, C, D and whatever meant. So I've went through a bit of a learning curve. Apparently class A amplifiers offer the best sound quality, but they're not very energy efficient. Class B is not as good sound quality as class A, but better efficiency. I can't remember what Class C did, but I'm sure somebody will leave it in the comments. And Class D is this type of amplifier. Now this uses PWM, or pulse width modulation, to generate an audio signal, which is then smoothed by the filter. And I'll connect it up to the scope in a moment and you can have a look at the waveforms before and after the filter. I'm going to show you what the waveform looks like coming directly out of the amplifier, and then what it looks like after the filter. So I've got a tone generator installed on my phone, so I'm going to generate a tone of 1000 Hz or 1 kilohertz. So that'll be displayed on the scope and you'll also be able to hear it, and we'll have a look at the waveform out of the amplifier direct and then after the filter. So I'll get the scope probes on here. So this is the waveform directly out of the amplifier, and if you notice in the middle of the waveform, in the middle of the scope there, you can see the sine wave, but there's loads of peaks all over it. And then if we look at it after the filter, you can see all of those peaks are gone. The waveform looks quite jagged still, but that's because it's a Class D amp, which is a digital amp. So that's the waveform after the filter. And again, this is the waveform before the filter. So that's what the filter does, it removes all of that noise. So I think they've tried to implement what's called a hybrid filter, and it obviously hasn't worked because there was quite a number of these units that had exactly the same fault. So it's not just this unit's failed. I mean, the guy's got about 25 of these in his garage, all exactly the same fault, all heating up, and he said he can get even more of them. So I think he just bought a job lot of 25. He says the guy he got them off, he's got something like a container full of them, so it must be a design fault. Either that or they've picked a wrong component or a wrong value capacitor that they've placed in here, or they've got the calculations wrong somehow, and that's what's caused the problem. But like I said, on the amplifier chip data sheet, they're just using a setup like this. So I thought, well, you know, let's go with that then, because that's what the chip manufacturer recommends. Right, then I think we'll give it a try and we'll see what happens. Right, so I've got it switched on. I'll just zoom out a bit. And I'll just get my phone here. So I think what we'll do, we'll get it playing some music or something. And we'll just leave it playing on a loop, and then we'll come back and see how things have heated up or if they haven't heated up. So I've got it connected to my phone. And what we'll do, we'll just play some music here.
A few moments later.
Right, so let's just have a look at the temperature just for now. And I have had this running a little bit, but not for very long. Let's put this onto video so we can record it. So the current temperature of the inductors is about 21 degrees. So what I'm going to do, I'm going to put it on full volume, let it run for a while, and then we'll come back and see what the temperature of the inductors are. Right, so I'm going to start playing some music and that now. We'll just put this on a loop. Right, so it's been playing for about an hour now. So let's see what the temperature of these inductors are. And that's saying about 39 or so. Let's just zoom in. Which is just over body temperature, isn't it? 37 is body temperature, so yeah, it's not too bad. It's definitely better than it was. Let's see what the main chip says. I'll just get it on there. So about 35, 36 degrees on the main chip, and the inductors are around about 39. Right, so it hasn't cut out, it's been playing for roughly about an hour now. So I think that might be it. So what I'm going to do, I'm going to reassemble it all, and then we'll give it a final test, I think. I have to and bend that cap back down. Right, I think that's it. We'll just take it back upstairs and we'll test it now with the subwoofer. Right, so I've had the speaker playing for about half an hour now. So we'll just get the thermal camera out and we'll just check that power spot. And we've still got a power spot there, or a heat spot rather. But now, it's only at 20 degrees. So that's a lot better than what it was. And it's not cutting out now. So I would say this one's fixed. Right then. If you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.